Um, so some backgrounds and context to this talk, real quick, are that this is really from a DevOps perspective. We work on a number of SaaS applications with some front end and back end API, and we experience continuously evolving requirements. We also do some data analytics on the data, although I won't be going over that today. And we have some pretty complex data relationships in some cases, and we're typically not dealing with huge databases. So that's kind of the context to this app dev. As we all know, the continuous cycle of development always starts out with some request from the client or the customer, and then it goes through a number of interpretations and translations, and we end up essentially needing to iterate fast to really get down to what the customer needs. So using Neo4j as a DB, we found that the iteration is a lot easier to do for a number of reasons. And those are kind of what I'm going to go over today. But namely the easy schema changes, easy to understand schema, and to be able to explain it and go over it. Easy to read queries makes onboarding new developers really fast and makes going over existing work much easier. Easy to visualize data, and then we'll look at some query flexibility. There are some cons in using a schemaless database that if you're not used to, they can pop up. They're typically all related to just the fact that the Neo4j is schemaless, and we'll go over some of those as well. So just to start, guess adding new columns in like a regular database is not always super easy, whereas adding them and renaming them in Neo4j just really is a breeze. We just basically pick what we're going to call the property and just add it to our dictionary, our DTOs on the code side, and that's it. We found that often from the database, we do return for a number of different queries. We return just properties, all properties of the node. And that also makes really not needing to update any of our queries when we add new properties or rename properties. Just some updates on the code side. Adding new nodes and new relationships, also something that we have to iterate through often as requirements change. And also, again, just typically the overhead is very, very low for us and allows us to iterate fast. We found examples where we need to add a truck might have many drivers, but they suddenly wanted to have a default driver. Adding just a relationship there solved that for us. Or splitting out data, drivers might have driver pay, and but they needed to be able to have a different pay based on different dates, and so we just pulled that out and create a new relationship with a new node that we just roll up in our queries. Track previous versions. Again, you just a relationship from one invoice to another in this example, and then instance nodes can be really powerful in Neo4j, where in this case an incident is a type of incident, and so all your props are stored here, and there might be some individual props pertaining to that incident here, and this is just an instance of that node. So little changes like that just cause us to need to continuously change the DB, but overhead is really easy with some of these APOC commands that we have access to in Cypher. Make it easy to rename stuff, but just in raw Cypher, I've got an example here of what it looks like to just make a complete carbon copy of a node, and then either give it a different label or in this case just give it a different ID. So super fast inside the DB itself. So easy schema changes. This is an example that I'm actually going to run through or skip just for time's sake, but kind of going over what we just talked about. One of the downsides, so one of the cons, are that relationships are not required or enforced at the DB level. So there's no constraints around that. When we have as mentioned earlier, we've got this incident type, which is a kind of an instance of an incident. Well, we always want this relationship to exist. It should always exist, and there's no way to constrain that. But what we came up with, some solutions that we came up with to kind of help us uh, manage some of these things are naming conventions. Any relationship that starts with is, we know that that relationship absolutely needs to exist to the other node, and that helps us, developers always make sure that that data is there, or throw an error, etc. Same with has. Has would be one of those where a has is always a one to many relationship that's potentially optional. So a truck can have many drivers, but default driver is always going to be one to one since it doesn't start with has. So some naming conventions help us resolve those issues. And then just running query tests on the DB regularly. When we run our tests, we also make sure that, in this case, I'm showing, um, find any nodes, any incident node that does not have a relationship to entity type, and then return the ID or return the node, and we can see what's going on. But our tests should all return like 0 results when we check for one to many, or any issues like that. So that's kind of our solution to con one. So not a big overall, not a big problem for us. Con two would be that properties aren't typed, but we found that actually enforcing schema on the code side is much better, and really mitigates the need to have that done on the DB side. We use things like TypeScript, Zod, and other typing languages and packages to help us do that. And then the third con is that Neo4j just simply doesn't scream at you when you ask for stuff that doesn't exist. It just says, sure, there's nothing. It returns nothing, but there's, whereas a typical database will tell you that that relationship or that column or table doesn't exist. So there's some, we found that always including a return helps know when that query actually executed successfully, even if you're not needing to return anything. So that's some mitigations around that. All right. So then another thing, so one thing that we found for iterating over our development is that the schemas are really easy to understand. I talked about naming convention around the relationships to allow us to, at a glance, know that, for example, movies has seen, meaning that this is going to be one to many. And that's going to be true for, well, we enforce those rules just ourselves. And that makes even complex schemas like this one, which is a NHL game schema. That makes that, even if this has a large number of nodes, it's still relatively comprehensible after 5 minutes. And the having these relationships between nodes, like such as these, eliminates the need for lookup tables and mapping tables with different statuses, etc. So that's really nice. So easy to understand, easy to go over with clients and others, and to discuss and to tweak as needed. Easy to read queries. I'm not trying to make everybody's eyes bleed, but this is actually a relatively long and complex query if it was written in regular SQL or MySQL. But in Neo4j, the actual query is just this, and the rest is just me rolling up the data to send it back in a payload. And this is really easy to read. There are 7 different nodes here, and at a glance, I can know that what's going on. For example, product has rate, and then rate has a rate level. I can see that this will be to be rolled up to the rate level, then into the product. And so, yeah, the queries are much easier to read and comprehend overall, which is actually really nice. The other thing is there's no subqueries at the bottom. Everything's at the top here. There's no joins or filters at the bottom of your query when you're doing your inner joins or left joins. So much more self-documenting from that perspective. And that's the result of this query. And that's our next point is that it's really easy to visualize the data. So that query that we were showing before has a product and rates, etc. And so using the browser or the app, it's really easy to kind of poke around and dig into the data and understand what's going on, or see why why something's not turning up the way we expect it to. And again, back to our naming convention, I know that this is a rate node because it's called has rate. I know that this is a rate level node. So just that naming convention also helps us explore and understand what's going on. This being a place node, commodity, etc. And sorry, I've been going through fast, but we got one more. So the big thing, and honestly for me the biggest pro that really helps keep our code clean, keep us iterating through fast, is that a lot of the logic, the ETL stuff that we have to do with the data is actually moved directly and done directly into the queries. Neo4j offers like a lot of functions that you can do and update nodes, create nodes, and do all that directly in the query itself, and just return the results. So using stuff like APOC doin in this example here, I'm just checking to see if an SSORL exists. If it doesn't, then I create it, I attach it to the node that I want it to be attached to, and then I return it, and do whatever we need to there. But I'm creating nodes, deleting nodes, updating relationships just on the fly and within the queries themselves, which makes it very fast and also moves that complexity away from the code. So the code is a lot more streamlined. Again, using call, same concept here, but in this case, we're fetching a one-to-many relationship, but I'm just using a filter on the dates, and I'm just returning one node that's the actual current tax rate based on the sale date in this case. And then this one's the last one's a pretty cool one where we stored on our compliance node, we stored the actual nodes that it should be applied to, and we can just unwind that compliance, which is an array, and then we match any entity that has a label that's equal to this compliance. So as it unwinds this, it'll fetch the driver, truck, and operator nodes, and then do something on them, whatever we need to do. That's essentially it. The recap is that really we found that Neo4j helps with rapid iteration, schema discovery and design, and planning with the product owner is a lot easier because it's understandable by them and accessible even to laymen. And query maintenance is low impact, schema self-documenting, code is cleaner, and data is easy to debug. And that's it. I don't know if we have question time or anything like that.